Hey, so no one talk when I talk. So you all know that the AP test is worth 108 points. I've shown you the scoring that shows that if you get 72 of those 108, you get a 5. So there's a lot of points you can miss. So when I help people, I'm always paying attention to the priority. Like how important are these points? This one, out of 108 points, I'd say this concept is worth to you, like knowing the concepts required to get this question right are worth about 10 points on the AP test. That's a huge chunk, okay? Because 60 is a 4, that means 1/6 of what you need to pass the test you can learn from this one problem, okay? Here we go. This is which of the following is a solution to the differential equation? So you have a flashcard that has reminded you that, oh yeah, to solve a differential equation, to find the solution of a differential equation, I need to follow this acronym. So I write down the equation. Separate. So I multiply both sides by dx. And again, no one ever got better at the ACT, at the AP test by just taking tests. You get better by seeing why you're not getting points and figuring out how to get those points. So as we're discussing this in class, make sure you ask about anything I do that your brain goes, hey, wait a minute, where did that come from? Why did you do it? How did you know to do it? That's how you get better. So I'm going to multiply both sides by y. Questions to that point? If this were an FRQ, you'd pick up a point for just doing that. Separated. Okay, next step is to anti-differentiate both sides. Lots of AP questions involve finding an antiderivative. That's why this problem has a lot of points associated with it. So this is y squared over 2. This one's x cubed over 3 plus the constant. If you do that on the FRQ, you get another point. And we want to talk about that. Keep going. So let's see. I need to find the constant now. That's what the C stands for. So I'm going to plug in the constants they gave me. So when x is 3, y is -2. I always replace variables with parentheses to prevent mistakes. So 3 cubed over 3 plus the constant. So this is 4 divided by 2, that's 2. That's 9. So the constant is -7. And we want to talk about any of those steps. Like how I did it, why I did it, what I'm thinking as I do it, anything like that. Cool. So now I need to isolate the y. So I have this equation, y squared over 2 is equal to x cubed over 3 plus -7. So I'm going to multiply both sides by 2. Oh, slow down. Keep talking.
Y squared, why did you put in the x? Like, so it says when y is 3, x is -2?
No worries. So 2 pebbles for a good question. You're just misremembering what that means. What they're saying up there is, okay, it's saying that the y function is a function of x. So it's kind of like saying f of x.
Oh, okay.
So the x is what's inside is the 3. No worries. The question.
And then the -2 is the one?
The -2 is the y.
Okay.
Yeah, that's no big deal. That's just learning the notation. And you're right, this is not a common way to say that, but that's what it is. That's a good question. You have to do what Kennedy just did. You just have to speak up and say, wait, I don't get that, and I'll help you. It's no big deal. So, there you go. So multiply both sides by 2. That's going to give me y squared equal to 2 multiplied by x cubed over 3 minus 7. Okay, if this is an FRQ, I don't worry about simplifying. Because it's multiple choice, I have to find my answer eventually. So I kind of notice that nothing here has parentheses, so I'm going to distribute. So y squared is 2x cubed over 3 minus 14. And now that's looking a lot like one of these, so that feels better. Questions about anything? Cool. So let's see. Got to take the square root. Okay, you need to have a flashcard to remind you that when you take the square root of two sides of an equation, the result is either the positive root or the negative root. Like this. If y squared had happened to equal 16, then y could either be a positive 4 or y could be a negative 4. So it's either the positive root or the negative root. The reason I know it's the negative root is because when I plug in a 3, I'm supposed to get a negative 2. So it has to be the negative root. So my final answer is y equals negative square root that. Separate, anti-differentiate, constantate, isolate. So, we want to please go.
So does that happen with every square root?
Yes. Anytime you're solving an equation, so what you want to memorize, Lauren, is if you take the square root of both sides, then you have to consider that your answer could be the positive or the negative every single time.
Wait, and then how do you know the positive and negative?
So the way you determine, Maddie, is you look back up here and you say, okay, let's do it with me for a second. So we're plugging in x equal 3. So you tell me what's 3 cubed. You can do it, just keep going. 27. Then 27 divided by 3 is 9. You're fine. 2 times 9 is what? No, 2 times 9.
Oh,
18. 18 minus 14 is? Good. Square root of 4 would be either a positive 2 or a negative 2. But I need it to be negative 2. That's why I knew that I had to have a negative here. If it had been positive 2, I would leave it positive. Is that your question? Good. No. Anybody else? All right, next one. Go to number 18, please. 18. Hey, don't talk to me. Hey, my turn, my turn, my turn. No one talk. Waiting. Hey, again, we're doing a lot of practice tests so you can get a lot of experience on how to find your way through new problems. Don't plan on passing the AP test by saying, well, there'll be a few that I know how to do. Don't plan on knowing how to do any of them. Plan on knowing how to find your way through them. And you find your way through them by doing one tiny step at a time, then you can get through a lot of problems. It says in the xy plane, the line, listen, come on, don't talk. In the xy plane, x plus y equal k is a line. So I'm going to circle that. I've got this line. I'm going to box this one. Don't make a mistake. So that's a line. K is a constant. That's nothing new. K is always a constant. So this line is tangent to this graph. Okay, so I said that the last one was worth about 10 points on the AP test. The concepts needed to solve this one are kind of in that vicinity as well, really, like 6 to 8 points. Because this concept is sprinkled throughout many problems. So we've got a line tangent, we've got a graph. We've done a lot of that this year. So I'm going to draw a picture. They didn't give me my favorite picture. So they gave me a lot of space. I'm going to use some space up here. So here's that curve. Okay. The line tangent is here. And this line is x plus y equal k. You notice I'm not trying to go fast. You don't succeed on the AP test by going fast. You succeed by going logically. Questions to hear from anyone? Awesome. Okay, the next thing is you need a flashcard to remind you that this key fact, I've said it many times, we'll say it again. This problem, this picture involves 3 equations. There's the line tangent, there's the point, there's the equation for the curve. So this is how we find every point on the line. We can also rearrange this to find the slope on the line. So I didn't draw the picture correctly, but that doesn't really matter. The slope of that line is -1. Because I rearranged my linear equation, I can see y equals mx plus b. So the slope of the green line is -1. So I've got this equation for finding these points. I've got this equation for finding these points. But I also now know the slope of this line. That's crucial. The third equation that's involved here is the derivative. So I'm going to go find that. So y prime is 2x plus 3. And I can use y prime to find any slope on the purple. Okay? Questions so far? You want to talk about any of it again? Please.
How'd you get -1 from the slope?
So I rearranged this by moving the x over. Are you okay with that? Then I remember that a linear equation that you learned, you've used this for years, looks like that. So the m, the coefficient of the x, which is -1, that's the slope of the line. 2 for Lou. Anybody else? All right, big idea again. 3 equations. I'm going to keep saying this for the next 26 days. We can use this equation to find any x on this line if we know the y. But you can do it the other way as well. If you know the y, you can find the x. Or we can find the slope of the line. So you get all of that from this equation. Slope of the line, you can find the x, you can find the y, whatever you need. This one, same thing. We plug in the x, we can find the y. Plug in the y, we can find the x. This one, we plug in the x, we can find the slope. We know the slope, we can find the x. That's what we're going to do. Yuli just saw it. I know the slope of the green line, -1. So that means there's some x that will cause this to be -1. So I'm going to solve that. Let's see, let's just do that here. So we've got y prime is equal to 2x plus 3. Well, exactly at that point, y prime is -1. Solving an equation means find the value that makes the equation true. So I know that the value that makes that equation true is x equal -2. So I know that this point right here is x equal -2. I can talk about that as much as you'd like, but this is a big idea on the AP test. Probably about 8 points in total that are available by knowing these concepts on lots of problems. Question? Cool. So I know that x coordinate is supposed to find k. Well, k is x plus y. So if I can find this y coordinate that goes with it, I've got it. So who can tell me how to find the y coordinate? Yeah, that's the purpose of that, is I can find any x, y pair on that curve. So I'm going to use that now. That was for Kenneth. So again, you're not succeeding on the AP test by remembering a problem, you're succeeding by remembering concepts and applying them one tiny concept at a time. Don't apply concepts simultaneously, just one at a time. So now I figured out that x plus y is -2 plus -1, so -3. Question? Oh, next one. 25.
Is this specific to our
No, I just ran a report. I think it was actually, I'm not sure how many periods it was for, but it tends to be about the same. Like when I've done it for different classes, it doesn't vary that much. Once you get a big enough samples. Plus, what I pick also is, again, I'm actually skipping some that people missed a lot, because out of 108 points, there's some of those that are worth like half a point, meaning they only test you on it once every other year. This one, about 8 points. Yeah, you want to know these ideas. So I try to hit the high priorities first. 25. So I read slow again. Let f be the function defined above. The other thing I do on the AP test, don't let them intimidate you. Like, whatever they give you, don't worry about it at all. Just move on. So they gave me f, I don't even think much, just move on. C and D are constants, that's normal. Stop there, I'm good. Okay, so I stopped at the period, nothing special, I keep reading. Okay, if f is differentiable at x equal 2, what is the value of c plus d? A flashcard memory that you need to have is, when you have a piecewise function, the piecewise function is going to connect either nice and smooth, meaning one function connects to the other in just a nice, smooth way, which means you can find the slope at the connection point. Okay, if they connect smoothly, you can find the slope at the connection point. The other kind of problem they've typically given you is a piecewise function that connects at a corner. So they don't connect smoothly. That means you can't find the derivative at the corner. Okay? I've also seen somewhere there's a jump in between. You can't find the derivative there either. But f is differentiable. Differentiable means f is continuous, so they connect. And they connect smoothly because I can find the slope there. That's what they mean by differentiable. You want me to talk more about that? So I'm supposed to find the value of c plus d. Okay, I don't really know how to start this problem other than to say, when I'm finding constants, I kind of ignore them and do stuff I've done before. Well, let's see. When I have a piecewise function, it's going to be differentiable. It's got to be continuous. So that means, and I'm going to do this kind of FRQ style to help you prepare for FRQs, that the limit, let's give it up here. So the limit, as x approaches 2 from the left of f of x, and if I'm approaching 2 from the left, that means I'm using this. So I plug in close to 2, I'm going to end up with 2 times c plus d. That's what happens as I approach 2 from the left. If I approach 2 from the right, that's going to be this one. So that's going to be close to 4 minus 2 times c. You don't want me to talk about why I did it, what I'm remembering, anything. Please, Laura.
How did you get the first one again?
So if the value of x is slightly less than 2, that's this portion of the piecewise.
Oh, so you plug in.
So I plug in close to 2. I'm kind of thinking close, so close to 2 is like that.
Okay.
2 points, 2 doubles, 3 out. All right. if f is going to be continuous, these two have to be the same. So that gives me an equation. 2c plus d has got to equal 4 minus 2c. Okay, you've all done this before. You have one equation and there are two unknowns, you can't find the unknowns. So that's just what it is for now. But if f is differentiable, that means I can also find the slope at 2. So I'm going to take the derivative of f. So f prime is going to equal, the derivative of this is just c. And that's for whenever x is less than or equal to 2. I know that the equal sign applies because they told me it was differentiable. If they don't tell me it's differentiable, I can't necessarily put an equal there, because there could be a corner or a jump. The derivative of this is going to be 2x minus c. And because the function is differentiable, the slope just a little bit before 2 has to be exactly the same as the slope a little bit after 2. So it's very similar to this. The limit, as x approaches 2 from the left, of the derivative, well, that's just c. And the limit, as x approaches 2 from the right, of the derivative, that's just going to be 2 times 2 minus c. So that's 4 minus c. You want me to comment on any of that? Please.
Wait, how do you know that find derivative of?
Gotcha. For a function to be differentiable, it must be continuous, and first has to be continuous. So that's why I thought, well, let's find the limits of left and right, and they have to be equal to each other. So that gave me some information. It's going to be differentiable and it's piecewise. That means the slope of each piece must be the same at the connection. So f prime is the slope. So the slope of this piece is always c, whatever that is. The slope of the other piece is always this. And they've got to match up when we're close to 2. So that tells me that these two have to be equal. That equation is much more helpful because I can now solve for the c. So I add c to both sides. So c is equal to 2. That was dramatic. Say again. Please, Laura.
So, would you only do the kind of derivative if you didn't have two constants up there?
Very good. If there were only one known, if there was only one unknown here, I could have found it. I just didn't find anything, so I just had to keep searching for something else to do.
Okay.
Bubbles, anybody else? Okay. If c is equal to 2, we can put that in here. So let's see, 2 times 2 plus d has to equal 4 minus 2 times 2. So 4 plus d has to equal 0. So d is negative 4. That tells me now that c plus d is 2 plus negative 4, negative 2. Question? Cool. One more. You should notice for a couple of these today that solving an AP question sometimes is a matter of one thing, do another thing, then start to see how the pieces fit together. Let's do number 3. Number 3 involves the product rule and factoring. So I would say those concepts show up in about another 6 to 8 points throughout the test.
When you say 6 to 8 points, do you have that right here?
No, what I mean is that if I look at the whole 108 points, So like number 3 right here, you have to know the product rule. Well, pretty good chance there'll be some other problem in the FRQ or the multiple choice where you have to know the product rule as well. So it's not only the point you're earning here, it's the point you're earning somewhere else. And then the other thing you have to know how to do to solve this is you have to know how to factor. And factoring will show up in 2 or 3 other problems. So if I combine all those, I'm saying that the concepts you're understanding here are worth about 6 points in total. Is that making sense? Okay. 2 coupled, figured it out. So it's the product rule. So I go to work. So I take the second function, x squared plus 2 cubed, multiplied by the derivative of the first. The derivative of the first would be 1. Plus the first function multiplied by the derivative of this. So that's 3 x squared plus 2 raised to the second power multiplied by the derivative of this, which is 2x. You want me to talk through that step here? It's just the product rule. If this were an FRQ, you could stop, but it's not. We've got to factor. It's got to look like this. So I see that there are 3 factors here. X squared plus 2 3 times. There are 2 common factors here, so that's what gets factored out. X squared plus 2 squared. This divided by this leaves x squared plus 2. This divided by this leaves x minus 1 times 3 times 2x. You want me to talk about that? I look over here and I think, okay, wait a minute. We're getting pretty close because I've got this part here. So I just need to clean up the middle. So here we go. The parentheses here aren't doing anything. This has to distribute. So this is 6x times x would be 6x squared. 6x times negative 1 is minus 6x. Clean up and I have my answer. Good job, you guys. See ya.